Intel KnightCorner processor, KNC in short, or in commercial name, Xeon Phi coprocessor. So this machine is a x86 instruction set machine, 61 cores. It's highly parallel and targets HPC workloads. The core are simple compared to a normal Xeon core, and they have a wide SIMD instructions. I won't talk much about that because we will see that later in the course. It runs what is called a simultaneous multithreading technique. It supports general purpose APIs, so OpenMP, MPI, pthreads. It's set up as a coprocessor on the PCI Express bus, and there is two main installations, one in China and one in the US. And the one in China is 33 petaflops. It's a huge machine, and the other one is a 5 petaflop machine, and this 5 petaflop machine has 500,000 of cores. So the architecture looks like that. The host is here, and it connects through a PCI Express Gen 2 to a ring in here to the cores of the Xeon Phi. The core of the Xeon Phi through this ring can connect to the memory banks. To keep the system consistent, coherent, the data coherent, there is some tag directory connected on the bus, and they keep track of all the memory accesses. So the caches are kept coherent on this machine. The cores are themselves running in ACMT 4 ways. I'm going to explain that next. And the vector instructions are 512-bit wide. This is very wide for such instruction. It's energy efficient. You get more than 1.3 gigaflops per watt, and the memory bandwidth aggregated is 352 gigabytes per second, and this is for a board that is consuming 300 watts. The SMT used in this machine, so this is threads managed by the hardware. So the core can fetch instruction from multiple threads. So in here, for instance, I have two threads, and so the core will mix the instruction from one thread with the instructions of the other thread. And the goal of this technique is to get independent instructions, so to get more instruction level parallelism. So for instance, assume I have two instructions and I have a dependency here. The first thread will provide the instructions to be executed, and instead of having this instruction waiting, you can actually start an instruction from another thread. And because they belong to different threads, the two instructions are independent. There is no dependencies between them. So this case, by using multiple threads, you can get a pipeline that is fully occupied during execution. However, this technique shares the source, the hardware resources, between the threads at a fine-grained level. So sometimes this can be inefficient. So on some execution, because you're sharing, for instance, caches can degrade. They can be less efficient because you are fetching more data from the memory that they can handle efficiently. So most of the time this technique is beneficial, but sometimes because you are sharing resources between threads, you're using the hardware resources, and in this case, for instance, if that's caches, you will degrade memory access time, and the total benefits will not be as good as if you were running only one thread on the course. So we are going to use OpenMP on the mic. You should have received the eraser connection key, and there is two ways we can use it. So native way, that means we do everything, we run the code directly here, or as a coprocessor, that would mean we have a code here, and we do, and this code does RPC, as we have talked about before when we were talking about accelerators, on the Intel KnightCorner. What we are going to do is to use this one for compilation, for instance, and we will log on this one to do the execution of the programs. Let's get more details about that. So, to connect on Phileas, that will be the host. Okay, you do SSH. You should have this, send you that, and this, your logging name. You get the file to compile. Then you need to edit the makefile. Okay, and you need to change GCC by ICC. And you need to specify that you want to compile OpenMP on the mic. Okay, so this is a cross compilation. So this compilation, so you need to set up the source, you need to source the path for the Intel compiler, and then you can do make. Make happens here. When you're done, you SSH on the KnightCorner, and then you can execute the code. So we have two questions here. The first one is why OpenMP default mode display 240 threads? And the second question is I want you to test different data size, different thread numbers to compare the performance between the host and the KNC on this code. To change the thread numbers, you can use OMP threads num. Okay, check this is the right environment variable. Some references if you want to learn more about the mic. And this is it for this, and see you in class.